all enough time to do every question, but I'd like you to try 1 through 9. Keep going on if you're waiting for me, but we're going to take 5 minutes to try numbers 1 through 9, and then I'm going to come back on and give you the answers to 1 through 9. Let's see if we got the same thing. So if this was a question on the test, find the x-intercepts. Did you write it as -5, 0, 1, 0, and 1, 2, 3, 0? You're supposed to write them as coordinates. Okay. And then this is counting by tens, right? Or fives, 5, 10, 15, 20. So did you count this as 10? 0, 10? Or did you call it 0, 2? Maybe you didn't read the axis, but it is 0, 10. Oh, okay. That's fine. 0, 9 I would count correct. Very good. That makes sense to me. Coordinates of a local minimum. So this right here is considered a local minimum because it dips, but then it goes down further over here. So did you call that 1, 2, -5? Or did you say 2, -4 maybe? Because these are counting by fives. 5, 10, 15, 20. Is that about what you got? Find the maximum. Infinity, right? It goes up forever. Oh, you said -1, but you just didn't read the axis. But now it makes sense, right? Okay. You had the right idea. Turning points, it has 2 places where the graph changes direction. Right here and right here. So 2 turning points. F of 2, what they want you to do is evaluate the function if you have 2, what? And we already set up here 2, -5. So whatever you put for your local minimum is also the value for this answer. They just want you to answer -5 is the value. Or if you put -4, I understand it's kind of just above that line. Parent function, it is cubic. So cubic is the only function with kind of that slithery curve where one goes up and one goes down. Is it increasing or decreasing between -5 and -3? So that's this section of the graph on the x-axis. So it is increasing, right? As I read it from left to right, it's going up. And is it increasing or decreasing from -1 to 1? That's this region, so it's decreasing. So aside from the little things like maybe writing it as coordinates, were you pretty much 9 for 9 on those? I think we should be pretty strong on that front page. So now we're going to do, well, these are all different parent functions, aren't they? So maybe what we should do is actually draw the parent function, and then you tell me what the transformation is, because these you might get a little stuck on. So does anyone know the name of number 10? That's the absolute value function. Can you describe what the parent would look like? I just did it in the back for someone, but yeah, go ahead, Anya. It's what? Straight lines, and it comes out of what point? Where's the vertex? 0, 0. All right, so you don't have to draw this on yours, but if this was the parent function coming out of the origin with a slope of 1, how would you describe the transformations that have happened? Give me the 3 transformations. Go ahead, Anya. Take a shot at one of them here. Okay, this goes up 4. Yep. Anyone want to tell me what these other 2 things do? The negative sign or the 3? Yep, it's going to flip upside down, right? So over the x-axis. So flip over the x-axis. And what does the 3 do? Yeah, it's going to have a slope of 3, steeper. So if I was going to graph this, I would shift the vertex up 4. I'm going to do it in a different color. So if I shift the vertex up 4, now my vertex is up here, and I'm going to go down 3 and over 1 for my steepness. So I'm now going to have a slope of 1, 2, 3, 1, 2, 3, like that. 1, 2, 3, 1, 2, 3, 1, 2, 3, like that. So it's steeper and it's flipped upside down with a slope of 3. So the absolute value function, you are going to get some of those on your test where you have to graph them by hand with the transformations. The other one, well, let's answer But why don't you take a minute and tell me what the domain and range are yourself before I say the answers, because this is also part of the question on the test, identifying the domain and range for that. All right, can someone help us out? What would you say the domain is? So X values, can I go side to side? What? Any real number. So you could write out the words, all real numbers. You could write out the boldface capital R. I don't like the infinity symbol used for domain. All real numbers is the better term. What'd you say for range? What about the Y values? Can I go up forever and down forever? Right, so all the Y values are less than or equal to 4. So that's the type of question that you'll see on the test. And then another absolutely fair game question is graphing a linear function, because we spent a whole unit on that. So could you skip down to number 12 and see if you can graph this y equals mx plus b? Remember, you have your y-intercept, you have your slope, and then answer the domain and range. Let's do number 12. I'm going to give you a minute to do that on your own. So I'm going to put it up. I start at -2 on the y-axis, and I go up 1 over 3 and down 1 over 3. So it's a straight line. Make sure you connect your dots with arrows. Straight line. This is not absolute value. It's not a quadratic. It's just a line. And then our domain and range for linear functions are always all real numbers in both directions, because the arrows go everywhere. All right, for example 11, I wouldn't have you graph this with transformations, but it would be nice to identify what the square root function looks like. It's a halfway curve, yeah. So if I was going to graph just the parent function, the starting point is at 0, 0, because the square root of 0 is 0. Our next perfect square is at 1, and the square root of 1 is 1. What's the next perfect square on the x-axis? Can I take the square root of 2 or 3 or 4 or 5? What's a perfect square? Yeah, 4 is a perfect square. What's the square root of 4? 2. I'm taking the square root. So what times what gives me 4? And then the other perfect square is 9. The square root of 9 is 3. So this is the parent function. I'm not going to have you graph the parent function, but you might have to recognize it's the square root graph. And then can you tell me the two transformation rules that are happening? Because you might have to identify from an equation what transformations are happening. Left, right, up, down. Anya? Yep, left 1 and down 4. So on the test, you won't be asked to graph this by hand, but you might be asked the transformation rules, or you might be asked the name to identify the graph. So if you wanted to finish graphing this, you could slide each of your points left 1 and down 4, left 1 and down 4, or you don't have to. Left 1 and down 1, 2, 3, 4. I'm just going to do those 3 points. So it goes that way. Now that I have graphed the new function down here, could you try to identify the domain and range from that new function? This is the key point that you're going to have to look at right here. So it's at -1, -4. Because that's the starting point of that new function. So that's going to affect the x-axis domain and the y-axis range. So see if you can take a shot at the domain and range using the inequalities correctly. I'll give you 30 seconds. All right, who wants to give me the domain? X has to be what? -1, right? Yep. And the y values are all greater than or equal to -4. Is that clicking maybe for you more now, how to do domain and range? So there's pieces of that question that I would ask you, but it wouldn't be one whole question on the test. Same thing for example 13. It'd be nice to know what the parent function of a cubic looks like, but I'm not going to have you graph it by hand, but I'll graph it for you here. 0 cubed is 0, 1 cubed is 1. Does anyone know what 2 cubed is? 2 times 2 times 2 is 8. So 2 comma 8, and then it's it basically goes down at the same rate on this side. -1 cubed is -1, and -2 cubed is -8. So it gives you this kind of curving graph in either direction. So when you see this, that's also a cubic function that's more pronounced.
How would you do that?
Oh, just start adding things like x cubed plus 2x squared minus 7x plus 49. So it adds a lot to the function that comes after it. Instead of it just being x cubed, you've got some x squared things, some x things. Let's see if this is a function that'll look like a curve. Yeah. So here's one. If I go to y max of 30. So like here's a cubic function that I just kind of made up, but it just has things after the x cubed, like 5x squared minus 2x plus 6. All of those pieces are contributing to that curve. All right, domain and range is always all real numbers for a cubic function. I'm going up and down forever, side to side forever. I'm trying to think exponential. It would be nice that you know like exponential increasing looks like this, exponential decreasing looks like that. I'm not going to be asking you anything too elaborate about that function because we spend a whole unit on exponential. Is that all? Cube root function, I probably will just completely disclude. I think you've got the parent functions, right? Absolute value, square root, linear, cubic, and then this page is going to focus on quadratic, which is what your quiz was on. So before we do this page, let's go over the answers to that quiz in intercept form. So before we do example 14, let's practice the box method to multiply this out. We need to put this into standard form. So I'm not going to ask you to graph it in this form on the test, but if we do the box method as a review, x plus 3 times x minus 1, I'm going to do the box and then distribute the 2 at the end. So why don't you try that box for just a second? And then when you write your trinomial, go ahead and distribute the 2 at the end. And let's see if we can put it in standard form together. And then you could try graphing it. We'll graph 14 and 16, and you can try 15 and 17. So here's what I got in my box. X squared, negative x, positive 3x, negative 3. So once you have your 4 terms in your box, you need to add any like terms together. So that's what I did down here. I have x squared plus 2x and minus 3. So then your last step is to distribute the 2, because there was a 2 as my coefficient. You're going to distribute the 2 into the trinomial. And then that should be your final. This is your function right here. 2x squared plus 4x minus 6. So when you're in standard form, the one thing that you have to memorize for your test is the formula negative b over 2a, being able to find the vertex in standard form. We've done it a bunch of times, so if you do homework 3.6 and 3.7, it'll help review that even more. What is negative b in this function? So yep, 4 turns into negative 4. And what is a in this function? So I'm taking negative 4 and I'm dividing by 4. So I get negative 1 as the x value of my vertex. It's also my line of symmetry. Now what do I do with the x value? Plug it back into that whole function. Owen, are you following along with us? We're on 14. Unpause. Okay. So if I plug in negative 1, I'm going to get positive 2 here, because 2 times 1. Then I'm going to get negative 4 and negative 6. So 2 minus 4 minus 6 is how much? Yep, because it's 2 minus 10 altogether, so -8. So I'm at -1, -8. So all that work was to find my vertex, but it practiced a lot of your skills, multiplying binomials, distributing, finding the vertex. Now I graph the function stretched by 2. So normally I go over 1 up 1. I'm going to go over 1 up 2, and I just crossed -6. I'm confirming that my y-intercept is -6 from the c value of the equation. And then I go over 2 up 8. So I actually am going to hit the x-axis with my next set of points. Does that seem reasonable? And I didn't show you intercept form, but guess what? -3 is one of the x-intercepts. +1 is the other x-intercept because 1 minus 1 gives you 0. And -3 plus 3 gives you 0. So that's why those are the x-intercepts, and that's called intercept form, but we're not assessing on intercept form. So you can try 15 and 17 in a minute. What'd you say?
Would we be able to get like plugging in the point that was like for stress, we'll be able to go like
Oh, what would it be? 3 squared is normally 9 times 2 is 18. So you actually could, right? If you wanted to squeeze that last point on, it would be way up here at 10, wouldn't it? Yep. And on the test, I'll just require that you do 2 sets of points on either side, but if you want to do all that fits, all the better. So I'm going to leave 15 and 17 for in a minute, you to try them, but 16 is in vertex form. So let's refresh vertex form. It's in vertex form because of this parenthesis, right? So just because you see parentheses, don't multiply it out. Leave it in vertex form. I'm just writing it so I can write the +0 right here. I kind of ran out of room. So what direction am I going? X plus 4 squared. So I'm going left, but I'm not going up or down. So just left 4 is my vertex. Don't multiply it out if you can see the vertex. It's flattened and it's concave up. So I have a positive a half. So normally I go over 1 and up 1. I'm only going to go up a half this time. Normally I go over 2 and 2 squared is 4. I'm only going to go up 2 this time. And then over 3 up 4.5. Those numbers should ring a bell. If you want to go further, go ahead, but it'd be what? 4 comma 16, so 4, 8. If you wanted to do over 4 up 8. So I might have time for you to go back and do 15 and 17, but I wanted to jump to the back page together. Let's see, multiplying to put into standard form. We just did a practice like that. 20 and 21, finding the vertex to put it in vertex form are optional bonus on the test. So I might have you try these in a minute. But I wanted to look at the application problem together, and then you can go back and try those other like 4 problems on your own. So if I gave you a function and you had to figure out some application about it, this says, what is the vertex and what does it represent in the situation? It says you may need to look at the graph on your own calculator, but if I had standard form equation, did any of you do the max min problems on Friday? How do I find the vertex if I know the standard form equation? Negative b over 2a, right? So couldn't I just calculate negative 140 and divide by 2 times negative 0.7, and that'll give me the x value without needing to look at the graph at all? So what do I get? This is what? The profit of a tutoring business. So depending on how many tutoring packages I sell, I make a certain profit. I don't know why if you sold more tutoring packages, you'd make less of a profit, but maybe it's because you use more of your time up. So you might be asked to find the vertex using an equation. So negative b over 2a, if I do it on my calculator here to save a little bit of time, comes out to be 100. Does that look like it's 100 on the, I guess it does, right? This is 100 right here. So that looks like the vertex, right? So 100, comma, can you make out the profit? All right, so I'm going to plug the number 100 back in. So I'd have negative 0.7 times 100 squared plus 140 times 100. And you'd have a calculator for the second half of the test. 7,000? Does that look like it's at 7,000? I could not read it. All right. And it says, what does it represent? So more importantly, I sell 100 packages, right? And 7,000 is my profit, my maximum profit that I can make. It might be hard for you to read the x-intercepts. What are the x-intercepts? What will they tell you anyway? 0, 0 is one of them. Huh? Yep, what's the other one? Let's see. Negative 0.7x squared plus 140x. I'll try to make it so you know that you can either read the graph or, let's see. Looks like the other one is at 200. I cannot read 200 on there, but the other one is at 200, comma 0. Oh, why does that make sense? The vertex was at 100. Isn't this a line of symmetry? So 0 and 200. If you did the max-min problems, the symmetry helps you answer the other x-intercept. What do they represent? If I sell 0 or 200 packages, what do I make? I break even. I make 0 profit, but at least I don't lose money. Break even point. And then what is the y-intercept and what does it represent? So the y-intercept happens to be 0, 0, right? If I sell 0 packages, I make 0 profit. At least I don't lose money. So you got about 5 minutes left. So I'd love for you to take a couple minutes and maybe just try the graphs. I think most of you are more comfortable with this multiplying binomials. I'm going to put the answers onto the video, like right now. Yeah. And then that way, if you want to check out 15, 17, and the last 4 questions, the answer key will be on Google Classroom for you. All right. Yeah, so it's done. All right, you should have tried 15. So now I'm going to take negative b over 2a. So 2 times 1 gives me negative 1. And then I get 1 minus 2 minus 7. So my vertex is at negative 1, negative 8, which makes sense because my y-intercept is at negative 7. So there's my over 1 up 1. I can go over 2 up 1, 2, 3, 4. And then if I want to, I can go over 3 up 9. And when I do negative b over 2a here, I get 1. And then 2 minus 4 plus 1 is negative 1. So 1, negative 1. My y-intercept is at 1, which makes sense because I go over 1 up 2, over 2 up 1, 2, 3, 4, 5, 6, 7, 8, because I'm stretching it twice as tall from that a value. All right, and then here are the answers to 18 through 21 so that you can check your work. So pause the video if you need to look at it for longer. I'm ending the video in 3, 2, 1.